Hello everyone, this is Heading Tian. In this video, we are learning 3.4 linear and angular speed. The linear speed equals distance divided by time. So V equals S over T, the ratio between the distance S and the T. Now, let's see the angular speed. Angular speed, it is omega. Omega equals the theta divided by t, the ratio between the theta, the angle, and the t. All right, where theta is in radians. What is the relationship between the v and the omega? Let's see. If I have a circle, and then there is a point is traveling from the point here. Maybe it's starting from the initial here, and then rotate the clock counterclockwise, got the second point here, and the linear distance is from the point to here. I can use the arc length. S equals r theta represent the S. This arc length. You make it straight. This is straight line. And the V, the speed of linear speed is the arc length is r theta over the t, S over t. And let's see, what is the theta over t? That's what we have learned today. The angular speed, angle over t. So the V equals R times omega. So we got the relationship between V and omega. And go back to the distance. S equals V times T. The V I have found equals R times omega. So R times omega, then multiply by T. So S equals R omega T. We relate the angular speed and the linear speed, also relate to the distance, linear distance, and the angular speed, omega. Let's see the first example. Use the formula S equals R omega T. To find the value of missing variable omega. Omega is missing. So omega is missing. How to isolate the omega? Find the omega. So by this formula, I can divide it by RT, both sides. Then RT canceled. Omega is isolated. So omega equals S over R times T. The given information is here has the S, R, and T. So omega equals 3 pi over 4 kilometer divided by R, 4 kilometer multiplied by 1 second. Then I'm having 3 pi over 4 over divided by 4, and then keep change flip 3 pi over 4 times 1/4. That's 3 pi over 16. And what is a unit? So this is the radian per second, because I know omega equals angle over the t. So angle is no unit, or you say the unit, we call this radian measure. And the t, most of the time we will use second. So radians over seconds. All right, if the question didn't ask you to round it to decimal places, you keep the solution with the pi. If you want to use your calculator, you can say 3 divided by 6, 3 pi divided by 16. Second, caret sign divided by 16. So round to maybe 4 or 5 decimal places, or round it to the hundreds. All right, let's see next one. Find the angular speed omega of a wind turbine with blades turning at a rate 34 revolutions per minute. Oh, I'm looking for the omega. The formula of omega is theta over t. So for example, if theta is 1 revolution, that is 2 pi. The angle theta is 2 pi. And now the given information is 34 revolutions. Use 1 revolution multiplied by 34. This is the angle theta. How about the t? So the given information is per minute. So in previous example, we say radians per second. We better to change the t, the bottom t per minute, make it into per second. So 1 minute equals 60 seconds. That means, oh, this is how many angles per second. Do the cancellation. What do I have? So 260, I got 30 left. Here divided by 2, 15, 17. So I'm having 17 pi over 15, and the degree, the unit is radian per second. All right, let's see next one. I think it's very easy. 75 horsepower outboard will, this is motorcycle, will rotate its propeller at 6,200 revolutions per minute. Find the angular speed, the same thing. Angular speed equals theta over t. So what is theta? What is the angle? It's nothing about the 75 horsepower. Maybe I have different horsepower. So the angular speed is nothing about this given information. So it's all about this. 6,200 revolutions. What is the angle? One revolution is 2 pi. And 6,200 revolutions, 2 pi times 6,200 per second. I want to convert minutes to second. So that's 60. Let's use our calculator to find the solution, because the question is asking right to the hundreds. And find the angular speed in radians per second. So let's find this. So on the top, I have 2 pi, 2 times pi, 2 times pi multiplied by 6,200. All divided by 60. So this is a solution. I can put this, let me write down, 649.2624817. The question says, round to hundreds. I will keep 2 decimal places. I'm having 649.26 radians per second. All right, let's see next one. A thread is being pulled off a spool at the rate 60 centimeter per second. The spool's angular speed is 100 revolutions per minute. What is the radius of the spool? So if I can draw some image. So for example, I'm pulling this. This is the spool. The radius, what is the radius, is not given, but it gave us the linear speed. If you see the unit here, centimeter per second, that must be the distance in some centimeter divided by the time in second. So when I see the rate of this, that must be linear speed. So linear speed is v. V equals 60 centimeter per second. And then another one, 100 revolution per minute, that's the angular speed, that's omega. Omega equals theta over t. So 100 revolution is how many degree, or what is the angle in the radian mode? So that's 2 pi times 100. This is the angle over the t per minute. The question, so we need to make them to have the same unit. So here is second. I should have the second here. So I can simplify, maybe simplify it later. I'm looking for the radius. What's the relationship between V and omega? V equals R times omega. Oh, that means R equals V over omega. So let's put the information inside of the expression. So on the top, V is 60. The bottom omega is 2 pi times 100 over 60. So keep change flip, keep the 60 and multiply by the reflection, 60 over 2 pi times 100, or we say divided by 200 pi. So I'm having 3600 over 200 pi. So let's do the cancellation. So 0, 0 canceled. I'm having 18 pi, 18 over pi. If the question didn't ask you to round it to decimals or integers or something, we keep this solution with the pi. All right, let's see number 5. Number 5, a belt runs a pulley of radius 6 centimeter at 80 revolutions per minute. Okay, so the belt is running this way, and then give us the radius is 6 centimeter and 80 revolutions per minute. Okay, omega, I can find the omega. The first question is find the angular speed of the pulley in radian per second. So number A, omega, looking for omega. Omega equals theta over t. Theta is the angle. 1 revolution is 2 pi, and 80 revolution is 2 pi times 80 divided by per minute. So convert minutes to second, that's 60. And then let's do the computation. So 0, 0 canceled, 2 plus 3, that's 8 pi over 3. Okay, if the question says round to the decimals, you can use your calculator. You say 8 times pi divided by 3. So you can copy the answer. But if the question didn't ask you this, so just keep 8 pi over 3. And number B, find the linear speed of the belt in a centimeter per second. So linear speed V equals R times omega. We have proved at the beginning of the video. And R is 6 centimeter, and the omega is, we have found in previous example in step 8 pi over 3. So I'm having a 16 pi. So this is a solution. You can also use your calculator to find your exact decimals. All right, we're done for today. I hope you have a good day. If you have any question, let me know. See you next video. Bye-bye.